We're going to find the equation of the tangent line where we have to find the derivative with implicit differentiation. Okay. So remember our equation, we always do point slope form, so that'll be y minus y1 equals m times x minus x1. Okay. They're always going to give us the x value. And remember, when we find the slope, that's the derivative, which in this case will be like our dy dx equation. Okay. If we need to find the y value, you're always going to use your regular equation, so the given equation, okay, not the derivative. So for these first few, we just want to find the slope of the tangent line at the given point. So they've given us both our x and our y values. So what I need to do is take the derivative. So that'll be 2x minus 2 plus derivative of y is just 1, but then I need to tack on a dy dx. And then the derivative of negative 3 will just be 0. So all I need to do to solve for dy dx is just move that over. So that'll be a negative 2x plus 2. Now that I found my derivative, I can just plug in 1 for the slope, and I don't even need the y value on this one. So that'll be negative 2 times 1 plus 2, which will give me negative 2 plus 2, which will give me a slope of 0. And so remember, any line with a slope of 0, that's a horizontal line. Now let's look at a trig one. So we're going to go term by term. The derivative of tangent is secant squared. Okay. It had a y with it, and I took the derivative. So I put a dy dx. The derivative of cotangent is negative cosecant squared. So that means the sign is going to switch. And then the derivative of 1 is just 0. So then to solve for dy dx, I'm going to move this cosecant squared over. So that goes to the other side. Then I'll just divide by what's with the secant, or sorry, what's with the dy dx, which is the 2 secant squared. And that'll let me solve for dy dx. Okay. Then from here, I'm going to plug in pi over 4 for my x value, pi over 4 for my y value. So to get the slope, that'll be negative cosecant squared of pi over 4 over 2 times secant squared of pi over 4. Okay. So I need to evaluate secant and cosecant of pi over 4. Okay, so pi over 4 is a 45, 45, 90 triangle. So that'll be 1, 1, root 2. Okay. Now what this means is you find cosecant first, then you square it, then you multiply it by the negative. So here I'll find secant, then I'll square that value, and then I'll multiply it by the 2. So when your trig functions are squared, what that means is this. Okay, so it's find the secant value first, then square it, then multiply it by 2. Same thing with the cosecant. Okay, it's only the cosecant value that's squared, and then you multiply it by a negative. Okay. So cosecant, that's going to be hypotenuse over opposite. So that'll be root 2. And then I'm going to square it, and then I'll multiply by the negative 1. Okay. Then same thing with the secant. Secant is hypotenuse over adjacent, so also root 2. Then I'm going to square it, then I'll multiply by the 2. So root 2 squared is just 2, so that'll be negative 2. Root 2 squared is also 2, so that'll give me negative 2 over 4, and then my slope will reduce to negative 1/2. Now from here, since we found the slope, now we can find the equation of the tangent line, and we're going to stay in point slope form at the given point. Okay. So this time I've got some derivatives with roots. So when I go to take this derivative, that'll be 1/2 x to the negative 1/2. The derivative of 2y is just 2. Tack on a dy dx. And derivative of 0, still 0. Okay. So then this term, I'm going to move the x to the bottom with the 2 and make the exponent positive and then move it over. So I'm going to go ahead and do that in one step. So that'll be a -1 over 2x to the 1/2. Then just divide by 2. So what we can do from here is, since there's no plus or minus, we can just multiply by the reciprocal. But since the derivative is in our answer, since the equation of the line is, I can just leave it like this and plug in these numbers and deal with the fractions and fractions later. Okay. But since this is a pretty easy one, I'm going to go ahead and simplify. So I'm going to leave this the same, change this division to multiplication, multiply by the reciprocal of 2, which is 1/2. And so that'll give me -1 over 4 x to the 1/2. Now to get my slope, I'm going to plug in 4 for x. There's no y left in here, so I don't have to worry about plugging this one into the slope. So that'll be -1 over 4 times 4 to the 1/2. Okay. And remember, 1/2 means square root. So this is -1 over 4 times the square root of 4. Okay, so you have to do the power first, and then you can multiply by the 4. So this will give me a 2 here, times the 4 is 8. So that's my slope. This is my y value. So to write the equation, that'll be x minus, it'll be y minus, sorry. So y minus y1, so minus a -1, equals m, which we just found, times x minus x1. Now let's look at a trig one. So same thing, we want the equation of the tangent line in point slope form. So we're going to go through our derivative. The derivative of cosine is negative sine. So that'll be -2 sine of y dy dx. Derivative of sine is cosine. And the derivative of root 3, that's just a number, so it's going to be 0. So then to solve for dy dx, I'm going to move the term without the dy dx over, and then I'm going to divide by what's with the dy dx, and then I'm going to go ahead and reduce these. Sorry, this is a sine of y. So that'll be -2 cosine of x over sine of y. Then to get the slope, I'm going to plug in pi over 3 for x, pi over 6 for y. So that'll be -2 cosine of pi over 3 over sine of pi over 6. So pi over 3, that's in quadrant 1. And remember, that's a 60-degree angle. That's 180 divided by 3, 60 degrees. So this is the bigger angle. So it gets the bigger side, which is the root 3. Okay. Then cosine is going to be adjacent over hypotenuse. So this part works out to be a half. And then I'll multiply it by the -2. Then sine of pi over 6. Pi over 6, that's 180 over 6. So that's the 30-degree angle. That's 1 root 3, 2. So sine would be opposite over hypotenuse. So 1/2. So you could just go ahead and cancel the 1/2s. Or if you multiplied it out, you'd have -1 over 1/2. And then you would leave this, change that to multiplication, flip that to 2 over 1 to get your slope to be -2. And then your equation will be y minus pi over 6 equals -2 times x minus pi over 3. Now let's go ahead and look at one more example. So I'm going to go ahead and rewrite this root. So then I'll go term by term. Derivative of cosine is negative sine. This would be minus 3y to the negative 1/2 dy dx. This would be a 1 times the dy dx, and the 6 will just go away. Okay? So I have more than 1 dy dx. So I'm going to take this term, move it over. So that'll now be plus 3y to the negative 1/2. And I'm going to go ahead and move that down to the bottom. Now the reason we want the dy dx's on the same side is so that we can GCF out the dy dx. And then we can divide by that. So for dy dx, we're going to get negative sine over 1 plus 3 over y to the 1/2. Okay. So if this question was just saying find the derivative, okay, we couldn't leave it like this because we have a fraction and fraction. So I'd multiply all 3 parts by a y to the 1/2. Okay, but this one, since it wants the equation of the line, I'm not going to spend time simplifying this. Okay, so I'm just going to go ahead and plug in 0 for x, 1 for y. So my slope will be negative sine of 0 over 1 plus 3 over 1 to the 1/2, which would just be square root of 1. Okay. Well, sine of 0 is 0, so that'll just be a negative 0, which is just 0. And then this would be 1 plus square root of 1 is 1, 3 over 1 is 3. So that'll give us 0 over 4, which is just 0. Okay, which tells us this is a horizontal line. So we don't have to do point slope form for horizontal lines. So remember, horizontal lines have a slope of 0. How you write the equation is y equals, and then you just look at your point and take your y value.